right, welcome back. So we worked on this problem in the previous video. It turned out to be this differential equation with these initial conditions, and we solved it. We did all the math and had this answer. But that's not the end. So we have to put this answer in an alternative form. We want this answer in an alternative form. It turns out it's just a sine and a cosine. If you were to graph this, it'd be a beautiful sine wave or cosine wave. But and we can put it in we can write it as one sine function rather than the sum of a sine and a cosine. So when we do, it's convenient. It's convenient for doing the derivative. It's convenient for seeing the amplitude. So we have to calculate this amplitude. We have to calculate this phase shift. That's A sine omega t plus phi. We don't have to calculate omega. Omega is the coefficient on t. It's the same coefficient on t here. It's 2, the 2t. So, by the way, what is omega? It's called the angular velocity. Angular velocity. Kind of abstract. You know, what did we do? We started this at 2. We gave it a nice upward push. It was an upward push. But that's down in my picture, and so it does have this sort of motion. It is just some sine wave, but I wonder what the amplitude is. Well, we can calculate A with this. A is the square root of C1 squared plus C2 squared. By the way, if you remember, this was C1 and this coefficient was C2. So C1 was 2, C2 was negative 1. So we can calculate the amplitude with this. And the phase angle, or phase shift, phi, we can calculate with this formula. The tangent of phi is C1 over C2. And one way to think about these is to think of this picture. If you go over C2 and up C1, then that hypotenuse of this triangle is C1 squared plus C2 squared square rooted. That's the amplitude A. And that's the phase shift phi, that angle phi. The tangent of phi is C1 over C2. So let's try it. The amplitude should be the square root of C1, that's 2 squared, plus negative 1 squared. Everybody knows that's 4 plus 1, that's 5. The square root of 5. That's the amplitude. That's A. Awesome. We can put this in the alternative form. Let's find phi. Now, phi gets a little tricky. Let's try this. The tangent of phi is C1 over C2. C1 over C2. That would be 2 over negative 1. That would be 2 over negative 1. That would be negative 2. 2 over negative 1. So so phi is the tangent inverse of negative 2. The tangent inverse of negative 2, or the arctangent of negative 2. So if you pick up your calculator and tell me what that is, you will get a number. Hang on. Yes, you will get a negative 1.107. Now here's the problem with that. According to this picture, C2 is on the x-axis, C1 is on the y-axis. If I drew this picture with my C2 and C1, I would have myself an angle over in quadrant 2. The C2 is negative 1, the C1 is up 2, over negative 1 and up 2, that my amplitude is that hypotenuse, square root of 5, and my angle is this phi. Is this angle phi. Well, what I just calculated was a negative angle. That, by the way, that's in radians. That's negative 1.107 radians. That's over here in quadrant 4. The reason, and that's wrong. Now your calculator knows about the restricted range of arctangent. Hopefully you do too. The arctangent will always give you an answer in quadrants 1 or 4. That's the restricted range of arctangent. So when we asked for the arctangent or the tangent inverse of this negative number, it gave me an answer in quadrant 4. But in reality, this problem, this picture is an angle phi that's in quadrant 2. So what do? I have to, it's 180 degrees off, I have to add pi to this. You have to be careful. Maybe you were in quadrant 4, maybe that is the right answer, but for this problem, the actual answer is in quadrant 2. I need to add pi to that. When I add pi to that, I get my phase shift of 2.034. So my alternative form is this. Square root of 5 was the amplitude. The sine of the omega was just the 2t, the 2 in front of the t, plus the phase shift of 2.034 radians. And that's the exact same equation as this. I mean, if you were to graph both equations, they land right on top of each other. It is this graph, and now I know the amplitude is the square root of 5. And if I wanted the velocity, I can take the derivative of this a little easier than this derivative. There's advantages to this alternative form. But you gotta watch out for the arctangent. That's that old thing gets students a lot. Hey, thanks for listening. We got more to talk about. Thank you. Bye.